Once again, good morning, everybody, and welcome to our Math 9 class. Today, we're going to talk about trapezoids. Last week, we have talked about quadrilaterals as a whole and about parallelograms, wherein two pairs of parallel sides and also of special parallelograms. We have talked about square, rectangle, and also the rhombus. Now we'll talk about trapezoids. Now, what is a trapezoid again? A trapezoid has only one pair of parallel sides and the other pair is not parallel. Let's start by reciting today's memory verse. And it's found in Revelation 7 verse 1. It says, "After this, I saw four angels standing at the four corners of the earth, holding back the four winds of the earth so that no wind would blow on the earth or on the sea or any tree." Today's MVCA boosters is about the trapezoid of life. Just like a trapezoid, a part of us are parallel, while another part of us intersects. Some of our life's reality is parallel to our expectations, just like the trapezoid's bases. However, some of our life's plans and expectations did not turn out to be the reality. Read Jeremiah 29 verse 11. What is God's message for you today? And you write a short prayer, especially as you begin a new year. Now, at the end of today's class, you'll be able to prove the Midline Theorem, prove theorems on trapezoids, and solve problems involving trapezoids. Let's start with our venture activity. And if you see this building, this is a building with trapezoids as its architectural design. The front design of the Amazon Court of Prague is made of geometric shapes. Trapezoids and rectangles are alternately repeated before a glass of exodermis in the center. Flamed and polished natural stone surfaces also interact with diagonal counter symmetry. So if you see the great ones and even the glass ones, it's an alternate of a trapezoid and a rectangle. Now let's start with our discussion. What is a trapezoid? As I mentioned earlier, a trapezoid only has one pair of parallel sides. These parallel sides are called bases. So we have base 1 and base 2, or you can interchange them, base 1 and base 2. And we also have, and the other pair is not parallel, or say non-parallel sides. The non-parallel sides are called the bases. So these two. Now, ma'am, what if I'll draw it this way. Wait first. Where's my pen? Here. Okay. What if I'll draw my trapezoid this way? Sorry, I'm sorry. This one. Like these two are parallel sides and the other one are non-parallel. So the parallel sides will be called the bases. So not all bases are at the bottom. It can be at the sides as long as it's parallel. So these are called the bases, while these non-parallel sides, these two are called the legs. Now, if in a trapezoid, the legs are congruent, it means they are similar and equal. So these two are congruent. Then we call it an isosceles trapezoid. just like an isosceles triangle. Remember, in an isosceles triangle, the legs are equal. So now, we also have the midline, or we call it the mid-segment or the median. Now, what is a midline? A midline is a segment joining the midpoint of its base. So example, this is the midpoint, of its legs. This is the midpoint of the first leg. So this one and this one are equal. It's a midpoint, right? If this is the midpoint, then this and this one are equal. So the line that connects the two midpoints of the legs, we call it midline. Or for some, they call it median or mid-segment. Now, how about an altitude? An altitude is a line segment that connects from the base, then perpendicular to another base. Example, from base 1 to base 2, and it's perpendicular. It means it measures 90 degrees. So we call this line segment an altitude. Now, how do we prove the midline theorem? The midline theorem states that the length of the midline is equal to the sum of the lengths of the bases. So for example, if BC measures 10 and AD measures 14, then the length of midline EF is equal to the sum of the bases, that's 10 plus 14 divided by 2. So the answer will be 12. So if you draw it, you see it makes sense, right? 10, 12, 14. So now how do you prove that? Here's the proof. And in your workbook today, in your quiz number 29, you need to have this in a 2-column proof. So you listen, how are we going to do this? Quadrilateral ABCD is a trapezoid with bases BC and AD. And the midline is EF. What do we need to prove? We need to prove that EF, the midline, is parallel. This means parallel to BC, and EF, the same midline, is parallel to the other base, AD. Another is, we need to prove that the length of EF is 1/2 of the sum of BC and AD. So now, we have drawn our triangle. That's the given. We need to draw segment BD. What is the reason for that? The reason is, it is by construction. We will draw the diagonal. So with the diagonal, we have formed triangles BAD. This is the one. BAD, the first one. And the other is triangle DBC. It looks like the other, this one. BC, DBC. Now let P be the midpoint of BD. So with this as the midpoint, then BP and PD are congruent. The reason, that's the definition of a midpoint. Remember, a midpoint divides the segment into 2 equal parts. Next, E is the midpoint, right? Therefore, AB, therefore AE is congruent to EB. And EP is the mid-segment, this one. EP is the mid-segment of triangle BAD. That's a definition of the mid-segment. Since F is a midpoint to CD, then PF, another one here, PF is also called the mid-segment of DBC. Now, since it's called a mid-segment, based on the mid-segment theorem of triangles, then we say that EP, this one, is 1/2 of the base, AD. And PF is 1/2 of BC. That is based on the mid-segment theorem. So we now have EF, okay. Let me show you here. Remember, EP is 1/2 of AD and PF is 1/2 of BC. So it means that we will add EF is equal to this segment, EP, plus the other segment, PF. The reason, that's the segment addition postulate. Now that is why it's very important once you go to geometry that you master the theorems that you learned in grade 7 and grade 8. Then let's do substitution. What's the value of EP? 1/2 of AD. What's the value of PF? 1/2 of BC. That is by substitution. Then we will, 1/2 is their common. We let it go out. 1/2 of AD plus BC. That is the distributive property. So if you see EF, the measure of EF is 1/2 of the sum of the bases, AD and BC. Now, the mid-segment theorem states that the mid-segment of a triangle is parallel to the third side. So if EF is parallel to BC, then EF is also parallel to AD. Now, let's try completing the statements. I have drawn here quadrilateral JKLM, and it is a trapezoid with MO as its midline. Now, prepare your check boxes as you will answer with me. Ready? The first one, A. If JK is 25 and ML is 32, what is the length of NO? Ready? In your chat boxes, share with me. What's the answer? JK is 25. ML is 32. So what's the measure of NO? Remember, NO is the midline. So NO is 1/2 of JK and ML. I have the answer, 28.5. Let's check. 1/2 of 25 plus 32. 1/2 of 57. So the answer is 28.5. Congratulations, Althea. You got the correct answer. That's 28.5. Very good. Next, here. Let's go to letter B. NO measures 26. ML measures 37. What's the measure of JK? Ready? NO is 26. ML is 37. What's the measure of JK? Let's check. Tatiana says 15. AP says 33. Let us see. Still the same, right? Midline theorem. NO is equal to 1/2 of JK plus ML. There's another answer, 31.5. Let's see. NO measures 26. 1/2 of JK plus 37. Now, to get rid of the 1/2, we multiply all by 2. So that's going to be 52 equals, this is 1, JK plus 37. So 52 minus 37 on the other side equals JK. Let us see who gets the correct answer. That's 13 plus 5. JK is equal to 15. Congratulations, Tatiana, for getting the correct answer. Next, let's go to letter C. If JK measures 6 cm and ML measures 11 cm, what's the measure of NO? Ready? In our chat boxes? Oh, that's very easy, right? Very good, Ali. NO is 6 plus 11 divided by 2. That's 17 divided by 2. Please don't forget the unit of measure. That's 8.5 cm. Okay, next, let's go to letter D. In letter D, JK measures 2x minus 5. NO measures 10. ML measures 3x plus 10. Find the value of x. Ready? JK is 2x minus 5. NO is 10. And ML is 3x plus 10. Find the value of x. We write the midline theorem again. NO is equal to JK plus ML divided by 2. Or you say 1/2 of the sum. NO is 10. We have an answer, x equals 3 by AP. Let us see. JK is 2x minus 5 plus ML is 3x plus 10 divided by 2. Let us see other answers. You simply cross multiply it. That's 10 times 2 equals 20. So you have 5x plus 5. Transfer to the other side. So 20 minus 5 equals 5x. That's 15 equals 5x. Divide all by 5. X is equal to 3. Congratulations, AP. Now, if you want to check it, you can substitute it. 2 times 3 minus 5. So that's going to be 6 minus 5 is 1. The other is 3 times 3 plus 10. That is 19. So 1 plus 19 is 20. Divide it by 2. That's 10. Very good. Now, let's talk more about isosceles trapezoids. Now, what is an isosceles trapezoid? Remember that in the chat box, can you tell me, in this quadrilateral LOVE, what are the legs? What are the legs? What are the legs in quadrilateral LOVE? Can you name them? Very good. That's LE and VO or OV. Now, LE and OV are called legs. So in an isosceles trapezoid, the legs are congruent. Now, since the legs are congruent, the theorem says that the base angles of an isosceles trapezoid are congruent. Remember, in a parallelogram, the opposite angles are congruent. But in a trapezoid, the opposite angles are not congruent. If you see from this picture, the base angles E and V are congruent, while base angles L and O are congruent. And here's the converse of the theorem. If the base angles of a trapezoid are congruent, if L is congruent to O, and if E is congruent to V, then trapezoid LOVE is isosceles. Now let's have an example. In an isosceles trapezoid LOVE, E measures 110 degrees. Find the measures of angle L, angle O, and angle V. Let's draw first. Ready? Prepare your chat boxes. Sorry for my drawing. LOVE. E measures 110 degrees. Now, can you tell me what is the measure of angle V? In the chat box, what's the measure of angle V? This one. Very good, Jared. 110. Nung 10 na lang AP. Okay, remember that this is an isosceles trapezoid. So base angles are congruent. So if E measures 110 degrees, then V measures 110 degrees. Next, can you tell me what is the measure of angle L? What's the measure of angle L? In the chat box. Let me give you a hint. Oh, very good, Tatiana, 70 degrees. Let me give you a hint. This is a quadrilateral, right? So in a quadrilateral, remember in a triangle, the sum of all the angles is 180 degrees. This is a quadrilateral, so you can make two triangles. So that's 180 plus 180. The sum of all the angles is 360. Say that in an isosceles trapezoid, consecutive angles are supplementary. So that's 70 degrees. Very good. How about angle O? What's the measure of angle O? Very good. It's also 70. Very good, Jared and Tatiana. Now, my next question. Why are they the same? Or what theorem supports your answer? Remember, in our workbooks, in our quiz, I'm asking for the theorem. What theorem supports our answer? Possible to 180, Althea, but there's no theorem that consecutive angles of a trapezoid are supplementary. Other theorems. What theorem? Sorry, it's so creepy, right? Wait first. What theorem? I think the first theorem. Oh, very good. Very good, Jared. Base angles of an isosceles trapezoid are congruent. How about, let's go back to our activity a while ago. How about in this activity? What theorem supports your answer? In this activity, what theorem supports your answer? In the chat box. Ma'am, oy, pwede solving lang, wala yung theorem. The theorem is our guide, so you need to remember them. What theorem supports your answer here? It's called the Midline Theorem. Remember that one, the Midline Theorem. What does the Midline Theorem states? That the length of the midline is equal to half of the sum of the bases. Now, this is an example of writing it in an SR table or in a 2-column table. You can read this in your module, but the answer will still be the same with this one. So I'll leave it to you, okay? Now, the next one, the last theorem. In an isosceles trapezoid, the diagonals are congruent. Again, the diagonals of an isosceles trapezoid are congruent. So if this is an isosceles trapezoid, then LV is equal to EO. Next, if the diagonals are congruent, that's the converse, baliktad niya. Kung ang diagonals congruent, then this trapezoid is isosceles. Let's have the last exercise. Sorry. In your module, I placed there NA. Akong gi-edit ni mong EA, mali na gihapon. That should be EO. Okay. Trapezoid love, L-O-V-E. So L-O-V-E. Dapat pasunod ang pag-name sa trapezoid, okay? L-O-V-E. LV measures 10x plus 9. While EO, please check your module, is equal to 8x plus 15. Find the value of x. Now, in your chat boxes, help me in this problem. Trapezoid love is an isosceles. If LV measures 10x plus 9 and EO measures 8x plus 15, we need to find the value of x. Now remember that our theorem states the diagonals of an isosceles trapezoid are congruent. So it means that LV is congruent to EO. Let's check AP if 18/25 is correct. So 10x plus 9, Tatiana says 3. Let's see. A equals 8x plus 15. To the other side, 10x minus 8x equals 15 minus 9. So 2x equals 6. Divide both by 2. Very good, Tatiana and Althea. X is equal to 3. Never mind. No, actually, I think what you did, AP, was you did not. Now, how to check that? You can check it by substituting. So let's have 10x, 10 times 3 plus 9, that's 39. How about EO? 8 times 3 is 24 plus 15, that's still 39. So they are congruent. They have the same measure. Congratulations, everybody. I believe that you're ready for today's quiz. Let me stop the recording first.